For this video, I'd like to talk about the idea of evaluating functions. So let me first give you an example. Let's say that we have f of x is equal to 2x plus 3. And we say this as f of x. So it doesn't mean multiplication, even though we have letters next to each other with parentheses. Parentheses usually do mean multiplication. Like if you see 2 times 3 in parentheses, this does mean to multiply, and it does give you 6. However, that's probably the biggest mistake that students make when dealing with this function notation, is they assume it means multiplication, but it does not. And the process of actually evaluating functions is fairly straightforward once you get the hang of it. However, most of the difficulty arises when dealing with the notation and just getting used to it. So let's say we have f of 2. And so what this means, in words essentially, is that given that x equals 2, let me make some space here, is the function equal to? And up until this point, you've seen it written more as an equation, like y is equal to 2x plus 3. And while this notation is useful, instead of having f of x, our new notation, just having the variable y, it runs into an issue when you want to ask this specific question. So given a specific x value, what is the y value? And that's where this equation notation kind of breaks down. And essentially to ask that question, you would have to write out something like this every time. But the function notation essentially allows us to compact this question into this notation right here. So we're essentially going to plug in x equals 2 and figure out what the function would be equal to, or what the y value would be equal to. Because in this case, we can say that y and the function are the same value. So whatever you get for f of 2, we would be able to plot this since we have an x value of 2 and we'll have a y value. So we can start drawing a graph of this function. But let's actually practice this. So when you see f of 2, we know that the x value is 2. So anywhere in our function you see x, you want to replace it with 2. So we have 2 times 2 plus 3. And I would always recommend substituting your number in, 2 in this case, inside of parentheses. And that will hopefully allow you to avoid making mistakes with negative numbers. When they're positive, it doesn't matter quite as much, but it's a good habit to get into regardless. So 2 times 2 is 4, plus 3 gives us 7. So this function goes through the point 2, 7, where 2 is our x value and 7 is our y value. So if we wanted, we could even plot this. Go over 2 and then up 7. So something like right there. And this is a line, so we can find a second point and plot that as well. So let's say we want to figure out what f of minus 1 is. So again, it's all about understanding this notation. So this is asking, given that x is minus 1, what is the y value? Or what is the function value? So now we're going to plug in negative 1 anywhere we see this x. So you get 2 times minus 1 plus 3. And here it does make a bit of a difference if you put it in parentheses or not. Because if you didn't put the parentheses there, you might write this looking something like this. And maybe you use a dot for multiplication, but it's easy to misread this. So I think, in my opinion, the simplest way to approach this is to just put it in parentheses, and that way you will likely not misread what you wrote. So you have 2 times minus 1, which is negative 2, plus 3, which is positive 1. So the function also goes through the x value of minus 1 and the y value of 1. So we found a second point on our function at minus 1, 1. And since we know it's a line, this isn't squared or multiplied by another variable or anything, we can connect them. You really only need 2 points on the line, and I didn't draw it perfectly, but it gives you at least a rough idea. So let's work through some different examples now. Say we have this function h of x equals 17 plus x over 6, and we want to figure out what h of minus 18 is. So just for clarification, when you have h of x, the variable on the inside, recall this is our independent variable. It's essentially the one that we choose, and then the function as a whole, h of x, or y in a lot of cases, this is what we call the dependent variable. Essentially, its value is chosen for us depending on what our independent variable is that we chose. So in this case, we're choosing to evaluate it at -18, and the function will tell us what the dependent variable is, or what the y value is. So we plug this in here. We have 17 plus -18 over 6. And if you want, you can put it in parentheses. That's mostly to deal with multiplication, but you can put it in if you want. And so you have 17, and then plus -18 over 6. 18 divided by 6 is 3, and the negative carries along, so we get plus -3, or just -3, which is 14. So essentially, if the function was equal to y, if this was our y value,